Before we start exact differential equations, let us revise a little about partial derivatives. So what are partial derivatives? We know ordinary derivatives already. For example, if y equals x square, then dy by dx equals 2x. This is called ordinary derivative. What if we have a function of two variables? For example, if we have f of xy equals x square plus y square minus, let's start with the easy one. Then the derivative with respect to x is called a partial derivative because now f depends on x, f also depends on y, f partially depends on x, and f partially depends on y. That's why the derivative with respect to x is partial derivative of f with respect to x. Let's go back to our ordinary derivative example and let's see what happens if we have x square plus 4. What is the derivative in this case? Dy by dx equals 2x plus 0, and it is still 2x. Why there is a 0 here? Because derivative of constant is 0. Right. When we take partial derivative, we treat all other variables as constant, okay? Just like 4 over here. So in this case, partial f by partial x will give us 2x plus 0. So that is 2x. We must remember though, the constant in derivatives have different behavior in different situations. For example, how about 6x square? Dy by dx equals, is derivative of 6 0 here? What do you think? No, derivative of 6 is not 0 because 6 is being multiplied with x square. Here 4 is being in the addition form. Okay? If it is plus or minus a constant, then the derivative is 0. If it is multiply or divide, then the derivative of constant is not 0. Rather, we write 6 multiplied derivative of x square 2x. So the answer is 12x. Okay. Right. How about if we have, we can calculate partial f by partial y as well, just to complete the story. Now because x square is being treated as constant, x is being treated as constant. If x is constant, x square is also constant. So derivative of x square is 0 because there is a plus here. Plus 2y equals 2y. How about if we had f of xy equals 10x y x square y cube? What would be partial f by partial x now? Now we are going to treat y as constant. 10 is already constant. So the situation is almost like this over here. Y cube is a constant number, just like 6. 10 is a constant number. So only x square is the variable thing here. So 10y cube outside the bracket, just like 6 outside the bracket. And what is derivative of x square? It is 2x. So our answer is 20 x y cube. Now note again, here y square's derivative was 0 because there is a plus sign, just like plus 4 here, that goes to 0. Here y cube's derivative is not 0 because it is multiplied, just like the 6 here. Okay? So that's a very notable point, and we shall not make any mistake in this. Partial f by partial y, what do you think? What should I keep outside the bracket? What is constant? X is constant because we are differentiating with respect to y. So if x is constant, it means 10x square is constant. 10x square is constant. What is the derivative of y cube with respect to y? 3y square, and that makes 30x square y square. Okay. Let's take one more example in the ordinary derivative cases. Y equals sine of 4x. What is dy by dx? First sine becomes cosine, and then derivative of 4x. What is derivative of 4x? It is 4. Derivative of x is 1. Okay. Again, the rule is same. These two rules are same because 4 is multiplied constant. So 4 multiply 1 and we get 4. So the answer is 4 cosine 4x. Let's try a similar example in partial derivatives. Let's say our f of xy is e power 3x square plus 4xy. This whole thing is in the power of e. Okay? What should be partial f by partial x? What do you think? What is derivative of e? What is the formula for derivative of e? If y equals e power f of x, just one variable, then y prime equals e power f of x, no change, into f prime x, chain rule. So here e power 3x square plus 4xy as it is, no change, into derivative of this thing, but with respect to x only. Remember, now we are going to keep y constant. Here there is no y, so that's all right. We can use the standard derivative 6x plus y is constant, 4 is constant, 4y into derivative of x 1. So we get 6x plus 4y into e power 3x square plus 4xy. How about you try, pause the video and try partial f by partial y. Right, I hope you have tried it. E as it is, 4xy, and now we are going to do partial by partial y of this thing. Partial by partial y, because we are calculating partial by partial y. So we are going to do partial by partial. X will be treated as constant. Now this term has no y in it. 3x square, no y. So it means this term is a completely constant. It goes to 0. No y here. Plus 4x into derivative of y 1. So this is equal to 4x e power 3x square plus 4xy. So it's almost like standard derivative. The only extra here is that when you deal with x derivative, you treat y as constant. When you deal with y derivative, you treat x as constant, just like we do here in standard derivatives 4, 6, 4 here. Right. Let's start the definition of exact equations then. What is an exact equation? A differential equation m of xy dx plus n of xy dy equals 0 is called exact if partial m by partial y equals partial n by partial x. We also write this condition as my equals nx. This y is written little smaller, just like you write x1. Okay, just like write x1. Okay? Subscript we call it. Okay, in mathematics. So this is written in the subscript, not multiplied. Okay, this notation is like this notation. Okay? Subscript. So if you take partial derivative of m, what is with dx, that is the whole thing is m. Okay, and whatever is with dy is n. They both can be function of x and y, just like I supposed here. So if you take partial derivative of this function with respect to y, and if you take partial derivative of this function with respect to x, and the answer is same, then we say the equation is exact. But that is just the check. So this check only tells me that the equation is exact. How to solve the equation? Well, we'll discuss in a minute. Okay, let's take an example. 5x plus 4y dx 4x minus 8y cube dy equals 0. The first important point here is that the equation must be in the form some function dx plus some function dy equals 0. The one with dx will always be called m with dx, and the one with dy will always be called n. Okay, we cannot change this thing. You cannot call this m and this n. No, that will change the story. Okay. So if you remember last time we were writing a equation like dy by dx equals something or something like this. Okay, but now we are writing dx m dx plus n dy equals 0. All right, so our m is in this case our m of xy. I'll write just m because clearly it's function of x and y. So I'll just write m. 5x plus 4y n is 4x minus 8y cube. So partial m, I'll use the short notation. Maybe I'll use both for the first time. Partial m by partial y. So what is the derivative of this thing with respect to y? X is constant. If x is constant, this whole thing is constant. So 0 plus 4. So my is 4. Partial n by partial x, that is nx. So derivative of this thing with respect to x. Derivative of this thing with respect to x, 4x gives 4, multiply 1 minus no x here, okay, because it's 8y cube. This is 0 and that is 4. Clearly we can see that my equals nx. This implies, jump here, working on it. Differential equation is exact. Right, so now differential equation is exact. What next? How do we solve it? Okay, that was just the part of check. This whole thing is just a check. That is just a check. So where is the solution? Solution can be written using a formula. It's a very clever formula actually. Formula says if your equation is exact, then integrate like this, mxy dx. This is not a very standard kind of formula. Books usually do not mention it. It's, you can say, it's a shortcut. Okay, So we'll follow it. And then terms of nxy without x dy equals constant. Remember that this is constant, not 0. Remember this constant. Okay, this is very important. Right. So mxy dx. What is mxy? All of it. We write whole mxy, which is 5x plus 4y in this case. Plus terms of nxy without x. Without x is a little bit confusing phrase here. Without x. Please pay little attention in the explanation of without x. Without x means, so how many terms do we have in n? Okay, let's see. Here, let's explain this one. How many terms do we have in n? N is 4x and minus 8y cube. Okay? Two terms. Two terms because in mathematics we don't consider 4 and x separate term. We consider 4x one term minus 8y cube second term. Now terms of n without x means this one. This one we don't want. The whole term. This 4 and x both gone. No, we don't want this one. We only want this one, the one on the right side. So we will only take this part. Okay? Not the first part. So how will it look like? The integral will look like minus 8y cube dy equals c. 4x we just ignored, deleted. Okay? Without x, do not write, let me make it clear, do not write 4 minus 8y cube. No, not like this, not like this. Delete the whole term. Delete the whole term, okay? 4 should also go, okay? Minus 8y cube. Okay, now we integrate. 5 x dx 4y is a constant with respect to x, so it can go outside. Minus 8 y cube dy equals c, so that would be 5 by 2x square plus 4xy, this dx will give an x, minus 8 by 4y power 4, or we can just directly write 2 equals c. So that is our answer. How do we know that this is the solution of our differential equation? So verification. This verification is not part of solution. Question is finished here. We are just doing it to understand what we have achieved. So df f of xy equals c, total derivative df, if we take the derivative on both sides, then derivative of constant is 0. And df is written as partial f by partial x dx, partial f by partial y dy equals 0. That's the formula for df in calculus. So if we take derivative of this with respect to x, what do we get? With respect to x, 2x, so that gives 5x. With respect to x, that will give 4y. With respect to x, that will give 0, so dx. Plus, with respect to y, this will give 0, 4x. And with respect to y, minus 8y cube. Dy equals 0. That is exactly what our equation was. 5x plus 4y dx plus 4x minus 8y cube dy equals 0. So that verifies our answer. You don't need to do this in exam. It's just in case if you want to verify or check your answer, then you can do this step in the rough work. Let's try one more. Right. We have to solve this equation using the exact approach. First, we have to write the equation in the form m dx plus n dy equals 0. Otherwise, we cannot check the derivatives. What we do is x dy equals 2x e power x minus y 6x squared dx. So this dx goes on the other side and multiply. Now we can bring them on the same side because they have to be equal to 0. That is very important to note, that the equation should be equal to 0 when you write m and n. Okay? 2x minus y 6x squared dx minus, this will go on the other side and become minus dy equals 0. Now we have the form m dx plus m dy equals 0. So our m is 2x e power x minus y plus 6x squared, and n is minus x. Do not forget this minus, please. Now we calculate the derivatives with respect to y for m. This will go to 0 because we are calculating with respect to y. So 0 minus 1, this will also go to 0. So the answer is minus 1. And mx is already minus 1. So this implies that differential equation is exact. Now we write, remember that this is the equation we are using, this one, in the form m dx plus n dy equals 0, plus we can say minus is part of it. Integral mxy dx complete, and terms of n without x dy equals 0. M complete, so we write integral 2x e power x minus y 6x squared dx. Terms of n without x. There is no term in n without x because there is only one term in n and it has x. So we will write nothing for this part of the integral. Okay? We will simply write not equal to 0, equal to c. And this is equal to c. Now we integrate 2. This is by parts formula, x e power x minus e power x minus integral of y will be xy plus 2 x cube equals c. So that is our answer. Please do this step in more details. Do this step in more details. Okay. Our next question is question number 27. Find k given that the differential equation is exact. So now we know already that my equals nx. So this is our equation, dx plus. So my, I'll write directly, my 3y square 4kxy cube minus 0, which is equal to 3y square plus 4kxy cube nx from here 3y square plus with respect to x 40 xy cube. Okay? So because differential equation is exact, it's given in the question that differential equation is exact, it means my equals nx. Already we know that. So this means 3y squared plus 4kxy cube equals 3y squared plus 40 xy cube. Very easy. We can see that this will cancel with this and we are left with 4kxy cube equals 40 xy cube. That means 4k equals 40, k equals 10. Let's see a special kind of exact equation. Question number 31 says 2y square plus 3x dx equals plus 2xy dy equals 0. Clearly our m is 2y square plus 3x and n is 2xy. When we calculate my, the derivative with respect to y, 4y, and nx, y is constant, and x, it is 2y. We can easily see that my is not equal to nx. So this means differential equation is not exact. Now let's write the question actually. We must see the question before we convert the differential equation into exact and then solve it. Sometimes question might give you a hint, sometimes will not, okay? Using an integrating factor. Where did we hear the word integrating factor before? In linear equations, we have used integrating factor. This one is almost the same integrating factor, but maybe formula is different, okay? The approach is almost same. Okay, so our equation is not exact, but the question says convert the differential equation into exact and then solve it. So how do we convert the differential equation into exact? There are two possibilities here, which we need to check. So let's see the two possibilities. The first possibility is if my minus nx over n is a function of x only, then I'll move this a little bit downwards so that we have more space to write. Then integrating factor equals integral e power integral f of x dx. This if will make the equation exact. Okay, if this is true, this must be function of x only, function of x Right. What if it is not function of x? Is there any other chance? Yes, there is one more thing we can check. That is nx minus my. Let's write it more. My over m. Note the difference. In this one, my first. In this one, nx first. Here, n is being divided. Here, m is being divided. Okay. And also here we have function of y only. Then if equals e power integral g of y dy. There are actually many more possibilities in literature in the books, maybe 10 of them or more even, but in this course we will do only 2 of them. So now our my is 4y, our nx is 2y. So we put in this formula and see if we get a function of x. If that doesn't work, then we put in this formula and see if we get function of y only. Okay, whichever works, we will go accordingly. My minus nx over n, 2y minus 4y. Well, is it correct? 2y minus 4y? No, 4y minus 2y. 4y minus 2y over, what is n? 2xy. 2x which is 2y over 2xy, that is 1 over x, which is clearly function of x only. So our first formula worked. It means our if equals e power integral f of x dx, e power integral 1 over x dx, e power log of x. Now there is nothing here, no constant here, so we can cancel e and log and we get x. Our next step is multiply. I'll number the equation so that we are not confused later. Let's number this one. Multiply equation 1 by if, which is x. Okay, so we multiply x into 2y square plus 3x dx plus x into 2xy dy equals 0. So we have changed the equation 2xy square 3s square dx plus 2x square y dy equals 0. Let me call this as equation 2. Right, let's check again. But this, if I have done these steps correctly, if I have done these first derivatives correctly, and I did this check correctly, and then I took the integration correctly and multiplication no error, this new equation must be an exact equation. Well, that's what the theory says, but just to be sure, we will check. Okay, my. Okay, well, it's okay to check on the rough work, or even if you want to make it part of the question, you can make it part of the question. This is your new m. I'm talking about now equation 2. Okay, I'm talking about equation 2, my. So here we take derivative with respect to y, that gives 4xy, this goes to 0, and x with respect to x, 4xy. Clearly this is exact. Right? This new equation is exact. Now we can use our formula. Okay? Integral mxy dx plus integral terms of n without x dy equals c So this is equal to 2xy square 3x square dx plus, there are no terms in n which are without x, so we don't write this integral. This just equals constant. And this one becomes x square y square plus x cube equals c. Right, let's have another look. So question says convert. This is convert into exact and then solve. Okay, so that is an important point to note. We are given an equation which is not exact, but then there are two possibilities. First, you check my minus nx over n, simplify and see if you get a function of x. If yes, then this integrating factor will make it exact. If this doesn't work, then you try this one. Can we guess? Sometimes we can guess by looking at the functions, but even if you cannot guess, it doesn't take too long to check, so just check one by one. First check this one, then check this one. What if they both don't work? Well, don't worry, I won't give you a question in which they both don't work. But as I said, in literature, there are many more possibilities. So my minus nx over n, 4y minus 2y over n, simplify, we get function of x, so that is the one we are looking for. If, integrate, cancel, that is our if, multiply equation with if, and it will become exact. Okay. Once it is exact, we can use m and n from here, this m and this n, and put in the formula and integrate. Okay. Let's try our one last example. xy dy plus 2x square 3y square minus 20 dy equals 0. M equals xy, n equals 2x square 3y square minus 20. Let's call this m. Question is same. Convert and then solve. Okay. And I'll add the question here. Convert the differential equation into exact and then solve. Right. So my equals x only and x equals 4x. Clearly, differential equation is not exact. Right? So we check. First we check my minus nx over n, x minus 4x over 2x square 3y square minus 20. Well, clearly it will not work. You cannot cancel y or x from here. 2x square plus 3y square minus 20. This will not go any further. So let's try the second one. Second one was nx minus my over m. So first write 4x minus x over xy. This seems to work. 3x and 3 over y g of y. So this one worked. Nx minus my over m, function of y only. So our if is e power g of y dy. Remember, this is dy, not dx. This one is dy. So our if equals e power integral g of y dy integral 3 over y dy 3 log of y, and that is equal to 3y. Is that correct? Did I make a mistake here? What do you think? Did I make any mistake? Multiply equation 1 with if. Have I made a mistake? Yeah, here is very. This is wrong. You cannot cancel e and log like this when there's a 3 between. You must move 3 into power of y, and then only you can cancel e and log. So our if is y cube, not. So y cube times xy dx plus 2x square y cube times 2x square plus 3y square minus 20 dy equals 0. Now again, if I have done the steps correctly, I am sure that this should be exact, but there is no harm checking always. Okay, so let's check here on the side again. My, this one with respect to y, 4xy cube, and x, this one with respect to x, 4xy cube, 0, 0, so that's equals, because my and mx are equal. So now we can use the formula. M dx integral terms of n without x dy equals constant. So m is xy4 dx. Term with x, we don't take this one. 3y5, yes, we can take that one because there is no x in this term. We can also take this one, minus 20y cube dy equals constant. Half x square y4, 6 by 6, so that will be 1 by 2 y power 6, 4 by 4, so that is y, and that's our answer. Please do the complete set of practice problems uploaded into website. This is the minimal set of practice problems. You must do these two at least to get a better idea of the